Yeah, I use these in the workshop, to be quite honest. Just a cheapo little set of Labtec computer speakers, and I use them when I'm testing sound cards, basically. And also when I'm just playing back YouTube videos, and rather than having the headphones on, I use these. And stopped working. This speaker isn't working anymore. Just this one's working, and I thought, well, I mean, I can buy a set of these probably for like €10 or something, certainly less than 20. But I thought, well, before I just go out and spend another €10 on some more, being a cheapskate, I thought, let's have a look, see what's wrong with them. This is the 12 volts coming in, yeah. So the first thing is getting into them. That doesn't look like it's going to be too much bother, because there's some screws down here, and the screwdriver happens to fit. So that's just begging us to actually have a look into it, really. The screw doesn't want to come out, but it's down there. So let's have a look, see if they'll come apart. Something holding these at the top. I wonder if you have to get this front bit off here, this cover, and then maybe there's another screw up there, because I can definitely feel something holding this at the top. Yeah, something doesn't want to open up. Do these? It looks like it. It looks like these just kind of like prise off. Yeah. Yeah, it's looking that way. Maybe. I'm being a bit brutal with these, but they only work on my bench anyway. There's a bit of test equipment for me, basically. Something's happening. This is where you lose some fingernails, but that goes to the territory. It's coming off. It's coming off. And inside there's a speaker, and there's a screw. So all that brutal mulling of that, there's a screw. The other one's still inside, it's kind of captive. So there's a screw up here as well. So let's undo that. Let's have a look to see if this will now come apart. I would thought the back would come off. Something's still holding this holding this together. Yeah. Can't imagine these go right through to the back, do they? Wouldn't put it past them, if they made this so all these screws effectively go through to the back. Yeah. I figure if I can fix this in like 25-30 minutes tops, yeah, it was worth the bother. It's not sort of thing I'd repair for something. I can't imagine anybody brought it in the workshop. If they did it, I can do it in half an hour. It's off €10. If somebody wants it fixing, I'm happy to do the job. Yeah. So let's have a quick look. So that comes out of there. That wasn't holding it all together. And there's not much of a circuit board in the bottom of it. I can see down in here there's a circuit board. That'll be the amplifier. The wires were all held in with glue, so it's obviously been made as cheaply as possible, and it doesn't want to come apart easily. I wonder if these knobs pull off or something to hold it together. One of the screws is still in here. Just check if that actually is completely unscrewed. It doesn't want to fall out the hole. Yeah. Oh, this isn't going to be easy to get into, is it? Let's see if we can just quickly check for some obvious things. Yeah, like do the speakers work. You can do this with a multimeter, or I use my analog meter for this mainly. I'll show you why. This is the only time I really use my analog multimeter. Yeah, so there's the analog one. Here's the fluke. If we go on resistance range, we can certainly check whether 4 ohms, that's looking good. Yeah, but it doesn't really tell us whether the speaker's any good or not. I'm seeing if I put it on diode mode, can I get a click? No, it doesn't make any sound. This is where my analog meter comes in useful, because on this it's got a buzzer mode. Yeah, you might hear the bleep, yeah. When I connect it to the speaker, it'll actually sound in the speaker. Now I know that speaker's working. This is the one that was working anyway. Let's have a look at this other one. So first I'm just checking whether there's a problem with this wire that goes from one speaker to the other. Yeah. To see if that's the cause of the problem we have with it. Once again, I'll undo these two. We'll take this front piece off. We know now this is how it comes apart, so we can be quite brutal with this, yeah. We know how this comes off here. Come off it, give it up. It's coming. There we go. Seems to be a little bit of glue. Yeah, there's just a bit of glue again. Ah! Now I can see why the back won't come off, because there's two more screws down there, yeah. There's two more screws down here. That's why the back didn't want to come off. This is why it wouldn't come apart on the other one. And we might need to do that if we want to get down to the amplifier board, yeah, and see what the problem is down there. So this has 3 screws here. 2 to the side. There's 5 screws holding all this together. There was only 4 holding the speaker in, so yeah, just take the speaker out would have been quicker. There we go. It's all apart. So we see the wire coming in. It's simply soldered to the speaker. Again, we can go on the fluke, and we can measure. We should see 4 ohms. Yeah, 4.3, close enough. We can stick this one on, and we should get a bleep out of the speaker itself. Yeah, I can hear it. Can you hear that? Like Morse code, I'm tapping it, yeah. So both the speakers work, so that ain't the problem. The next question is, have I got audio coming in? I've got it connected to a mixer that I use here. But we can check that. Let's now get this apart, yeah. We'll stick speaker back in here, because we don't want it, you know, waggling around and break the wires, yeah. Oh, this should just go back with a bit of effort. Doesn't want to go back. Isn't that funny? Came out easy enough. Ah, there you go. Look, it's in place. Did I undo them both enough? I undid them. So that one's undone. Ah, this one isn't. Forgot this one, yeah. And this one comes apart. So here we are. This is our super powered amplifier, yeah. In the bottom of here. It's held in by these wires, which are held in by glue. I can see where the audio comes in now. So the audio comes in here. There's a red and a white, yeah, down here. And the ground, so that's the audio coming in. That's just a little power LED that seems a bit bent, like the legs were trying to touch each other, but they're not. Again, obviously it's made as cheaply as possible. So, do we have any audio coming in? Well, that's a good question. We know both speakers work, yeah. But we don't necessarily know that the wires to the speakers are good. So let's have a look to see where those wires go to. So we have a couple of wires here. That's one of them. And looks like a couple of wires down here. That's the other one of them, yeah. So let's see. So we can get some sound out the speaker by clicking on these. So the two up by the headphone socket. Well, we know the speaker works anyway, so this one's okay. We know that one's okay. It's the other speaker that isn't working, which are these two. Yeah, can you hear it? Yeah, so that speaker's working. Again, if you don't have something to bleep like that, if we use the meter, it should tell us it's like 4.3 ohms or whatever it saw on the other end, yeah? 4.4 ohms. So both speakers are connecting to the amplifier, we can say that much, yeah? So the question is, why don't we have any sound on one speaker? Well, the next thing is going to be check as if we get any audio coming in. So that's this red, white and black here, and they go to here, yeah? How can we check it? Well, we could use an oscilloscope and see if we've got any signal coming in. But what I might try and do is, again, connect my little bleeper to here and see if I get some sound out the speaker. So effectively I'm connecting the bleeper to where the audio comes in on each channel. So one of them's there and one of them's here. That's the red and white wires. Can you see them? Let's go to the position so you can see them. There you go. So you can see now the red and white wires down here, yeah. So if we power this up, it has a little power pack, yeah, little mains power pack. So we power this up, and we use this the analog meter to eject the signal into here. We should get a sound, yeah, if the amplifier is working. So I've powered it up. Does it come on? Oh, no, it doesn't come on because you need to plug the the power in, yeah. Little green lights on there, yeah. Can we actually inject a signal with this? And this acting as an amplifier should come out quite loud from each speaker, yeah. So we can see all this main track around here is ground, yeah. If I go to there, that's where the power supply is coming in. This is the negative, yeah. So one of the audios is here, nothing. Other one is here. Okay, that doesn't tell us anything conclusive. I thought it would. That surprises me. I thought that would. Turn the sound right up. No. Oh yeah, I've got a little crackling noise on one speaker. Little crackling noise on one speaker when I touch that. You can't hear it. And I've got a crackling noise on the other one when I touch the other one, I believe. Oh, something made a noise, didn't it? Huh, something was making a noise. Okay, it seems that when I touch both of these, the audio coming in, I get a little clicking noise on each speaker. That's one of them. That's actually the speaker, the far end one, yeah, it's this one that's making a noise. So obviously this is like effectively becoming unstable, yeah, oscillating. So it would appear that the problem is with the audio coming in from the mixer. So what we'll do is now, this is where we'll just use an oscilloscope. I can't think of really another easy way to do this, and see if there's a problem with the audio coming in. Okay, so I have some audio playing, and I can see straight away actually there's a problem with the volume control. So I'm waggling that and it's coming and going, yeah. So I think the first problem, and probably the problem with this, is the volume control. Yeah. Yeah. So I think this is where our problem is straight away. But you can see the oscilloscope. So I've actually clipped the ground lead from the oscilloscope. I need to clip to the ground on here. And the easy place appears to be just to this leg of the switch here, yeah? So, let's see if we actually have audio coming in on both channels. Well, you can see straight away we haven't got a good ground. I don't have a good ground, I can see that. Let's just turn the sensitivity down a bit on the oscilloscope. But okay, so we need to get a good ground. Okay, so I obviously didn't have a good ground there, as you can see. And this is very intermittent. I'm going to connect it. You can see that the audio comes in here, yeah? Right and left audio here. And this is ground. And that ground is connected to this large area here. So this appears to be ground. So I'm going to connect onto there. And that ground area. And now see, yeah. Just turn the sensitivity up a little bit on the scope there. Okay. So you can see you've got audio coming in there, yeah? Let's go to the channel. Yeah, so there's clearly audio coming in on both channels, yeah? But waggling the volume control has caused it to come and go, yeah? So, yeah, I'm pulling on it. Yeah, pulling on this helps, and I've only got audio on one speaker, yeah? So this speaker still isn't working, yeah? So it appears we've got a problem with the actual volume control. Yeah. Coming and going there. Okay, so let's see if we can desolder that. Okay, so I've turned the audio input off now. But it seems that this is very intermittent. As I pull on this, I was getting sound through one speaker. It's breaking up, it's coming and going. The other speaker has no sound. So this is like a dual potentiometer or variable resistor, yeah? So inside like two horseshoe shaped tracks, and there's a slider which moves along them. You can see quite clearly the audio which comes in here and here. Let me find something to point easier with. This is ground, yeah? This is where I eventually had to get a ground with the oscilloscope. I didn't connect it to there, I ended up connecting it down here, yeah? But you can see all this pad area is all connecting together to this is all ground, yeah? This point I was connecting here wasn't a ground, that's why I couldn't get anything connecting over here, yeah? Your audio comes in here and here, yeah? So this is to one end of each track of the potentiometer. The other two sides are connecting to ground, yeah? And these are your output. So when we turn this way, effectively the slider inside here is connecting the output to ground. The more we turn it this way, it's increasing the resistance between these and decreasing between these. That's why it gets louder, yeah? And this potentiometer seems to be no good. I think one side this speaker channel is very intermittent, and the other speaker channel is probably not connecting at all, yeah? So let's just desolder that. I've probably got a spare one I've taken off some scrap equipment or other, yeah? Let's just zoom out slightly as well. Okay, so this should be quite easy to desolder, I think. We'll use just solder and desoldering braid, a little bit of flux. Got off a nice new tube of flux now, and I've ordered 3 more tubes of this. So I'm getting through quite a bit since I've had the YouTube channel, to be honest. See if we can get some flux out of it. So the new flux tube doesn't seem to want to work. Oh, there you go. Just wanted a bit of persuasion, yeah. Once it gets going, it'll get going. So there are flux. I think the flux has just dried up a little bit actually. Hopefully it's just at the bottom and not the entire tube. I have ordered some more today, but it'll take a few weeks to get here. So again, we'll just let it solder on here. Let's just be sure actually that the problem isn't an intermittent connection. Because with these large components, it's quite possible to have like fractured joints, yeah, what they call dry joints, dry solder joints. You know, due to vibration, it getting knocked around. So first, let's just actually check to see whether that now gives us some audio. Okay, so we now have some audio. Yeah, but only on one speaker. So this one's working. Yeah, that one's not working. But it's a lot more stable now, so we can actually have a look. Yeah, off it goes again. It's a bit more stable, yeah. So we can see where the audio comes in, here and here on the two channels, yeah. It goes into the potentiometer. Sorry, shouting over that, aren't I? It goes into potentiometer here and here, yeah. And these two ends are connecting to ground, yeah. So the output is here and here on the slider, yeah. And as we move the slider, the volume here, the amplitude will change. So let's see what we've got now. So we know now there's a grounders here, yeah. So we've got ground. Right, so you can see on the oscilloscope we have audio coming in on this channel, yeah? And audio coming on this channel. But we have audio coming out on that channel. Oh, we have them both now. Are both speakers working? Yes, they are. You guys can't tell, but I actually have audio now on both channels. Yeah? But still, it's very intermittent here. So it's now working on both speakers, so we know the amplifier is working, but it's very intermittent, the sound. So basically we need to change this variable resistor, and then it should be good. The camera just fell off, the one that was on the oscilloscope, but we don't need it right now anyway. So let's unsolder this. Bit of solder braid, nothing complicated here. Let's solder braid, and let's see if we can actually get this off. Yeah. Again, I'll put a bit of flux. I'll put a bit of flux on the braid. Actually, that's usually the easy way to do it. The being a new flux, the plunge just fell out. This is not. This flux isn't working very well at all. I would have a few more tubes of it, but I'm having to put a great deal of pressure on this just to get anything out of it. Pain in the backside that is. I don't think we'll desolder it without flux. Okay, so the flux is failed at the moment. I'll have to find another one. What else do I have? Well, when push comes to shove, let's use this stuff. This is the flux I used to use before I had that one, yeah. This one you kind of have to melt. It's a hard flux, yeah. So with this, you have to melt like a little trough in it with a soldering iron, and then dip the braid into the trough, yeah. So with this stuff, you basically melt away like a channel, yeah, and then just dip your braid into the channel, yeah. There you go. That's got some flux on it now for sure. Let's see if we can unsolder it. That one's come off. I think I've got that one. And we can always use the, I've got a vacuum desoldering tool that I can use, but let's see if we can just do it with basic equipment, yeah, which I'm guessing, I'm sure some of you guys have got basic equipment. So let's see if we can do it with the basic equipment, and then we just resort to the, the more expensive stuff when we need it, but at least we've proven that we do need it, yeah? And then you can see what you can do with basic equipment and what needs a little bit more investment, yeah? So that one was off. That one's off. Come on, little bugger. Yeah, so it's just this first one. I think this first one we probably have to apply a bit more fresh solder to it, yeah? I think I've mostly got it now. Let's put a bit of fresh solder on this one. Just cut off the scummy bit that we've just used, yeah? Let's just... see if we can unsolder this. It might be free now. A little bit of waggling, I can see that. Yeah, it is free, but there's like a metal. No, there's nothing holding it in. The way to test this is whether we can actually waggle each of the pins, yeah? So if we find something to just push on them with. Find this might be the last one I pick up, yeah? Yeah, something like this. And we can see whether or not each of these pins is actually free. That one is. That one is now. That one isn't. That one isn't free. So that it wouldn't move. Yeah. So just push that one a little bit further forwards. What else do we have? That one I think is free. That one isn't free. It's moving the pad with it. I've got to be careful I don't rip the pad off the board. See if it's free now. And then this middle one, it seems to be free now. Okay, let's have another go. It's mostly out. It just seems to be this end that isn't coming. So let's just warm it up and try and extract it. There you go. Okay, so this is the potentiometer. And I can see straight away it's broken. Let me zoom in on it. And you can probably see without zooming, but let's just zoom in. Yeah, can you see? It's actually fractured all the way across here, yeah? So that's fractured. It's broke. It's probably had some sort of impact hit the knob, which has forced it back and fractured across here. That's why it's so intermittent, yeah? This knob should come off it. There we go. So something's hit this and bashed into this. So it's rated A10K, yeah? 10K is the resistance of each track, 10 kilo ohms, yeah? The A is an audio one, so this is, you have two sorts. You have linear, yeah, and you have logarithmic. And A is the logarithmic. What logarithmic means? Let's explain linear first. This is a 10K, yeah? So if I put this operates a little slider inside which is connected to this one, yeah? If I put 50%, it's 10K, that'll be 5K, yeah? At 25%, it'll be 2.5K. It's like 75%, it'll be 7.5K, yeah? That's linear. With an analog, with a logarithmic one, it doesn't work like that. So effectively, the more you move it, when you move it a little bit, it might only add 100 ohms, yeah? When you move it the same amount, it adds 500 ohms. Then you get the same amount again, it adds another 1,000, yeah? And then the last part maybe add another 5,000. So that's how a logarithmic works. Since we got it, let's just let's try and make this basic video a bit more interesting, yeah? See, the cameras fell off here again. I'll straighten it up when we need it. So what we've got is, we know it's broken. Let's have a look inside it, shall we? Let's just see what is in these things. So basically I'm just forcing these little metal clips to go outwards, yeah. Same on the other side, just get this little blade edge underneath them, yeah. And the last one. There you go. Okay, so what's inside here? Yeah. Just bend these outwards a little bit. Yeah. There you go. So what's inside here is like a horseshoe shaped resistive track, yeah? And from end to end, this will read 10 kiloohms. So from one end to the other end is 10 kiloohms, yeah? And the middle one goes this metal ring, yeah? And the metal ring, if you look, moves this slider. So inside here is a slider, yeah? Can you see it moving? Yeah? And on the slider, you can see it now, there's like a little springy thing. So the springy thing pushes against this track, yeah? And depending where the springy thing is, depending where the springy thing is along here, that'll vary the resistance between the middle one and either end, yeah? So the springy thing towards this end, it's mostly connected here, low, and this will be high resistance. Move it the other way, this is low, this is high resistance. And that's how it works, that's how it works. Your audio comes in on one end, ground on the other, and your output will depend on where the position is. So that's the thing. So let's see if we can find a suitable replacement for that. And the answer is no, I don't have any suitable replacements for that. The only ones I have that would physically fit, and these are salvaged, are these ones. First of all, they're B, which means they're linear, not logarithmic, and the value is like 10 times the other 100k. But I could do with the speakers working, and speak-wise, I have a mixer that these are connected to, so I can probably control the volume from there. I could actually bridge these out. Thinking about it, I could just solder wire from here to here and from here to here, and then just use my mixer to alter the volume. But you know, I could do that and get away with that, and then possibly just order, you know, get a few replacements, because it's not going to be expensive. But let's just see what happens if we put one of these in, yeah, 100k. And linear, yeah, it's completely the wrong value, but out of interest, let's see what will happen. I'm sure it'll work, and again, I'm sure I can use my mixer to get the volume. I'll probably find what happens is that I get no alteration in volume till I've turned it like almost all the way across, and then like there'll be very little difference between full and nothing, yeah. But let's have a look, you know, let's see. We can soon take it back out again, yeah. We can soon unsolder it again. It's not a problem. So let's stick completely the wrong part in. Let's see if we then have two working speakers, yeah. And if they're working for now, I can just order a handful of those 10k logarithmic potentiometers. They'd be cheap enough. Okay, so that should be turned all the way down, but let's see what happens. Yeah, let's see what happens. We'll put the speakers back on, and we'll need some audio coming in. So let me just get the audio running again. Okay, so turn the speakers on. There's no sound now. Seems this is a dodgy one as well, or some other problem. Okay, so that hasn't helped a lot, yeah? I have both speakers working, but I still have this problem. Okay, Let's see if we can eliminate this. I'm going to desolder this again, yeah? And what I'm going to do now, I'm going to connect a couple of resistors just from here to here, say like 1k, and then say 9k to ground, yeah? Or maybe 50-50, maybe like 4.7k, 4.7 down to ground. So I'm effectively going to simulate this is turned off volume, and then use my mixer to actually control the audio level, yeah? So let's try that and see if that helps us. Get a bit of braid. Where's my cutters? Yeah, there they are. Get a bit of braid, don't need that in there. Well, let's desolder this again. Okay, that one's desoldered. That one's going to be desoldered in a minute. Desoldered. That's definitely desoldering. That's a bit warm, yeah. That was getting a bit warm. I was a bit close to it. Let's once again, let's dip the this is the flux, yeah. Let's dip the brake back into the flux again. I'll have to sort out the other one. There you go. Plenty of flux on that. Okay. So let's see if we can desolder these. Okay, that's got that one. It's got that one almost. Try again. Yeah, it's mostly got that. Might be stuck on one side. Back to here again. Yeah, take this off. I mean, this is a salvage part, so it could well be faulty, or it could be that, in actual fact, the intermittent connection is somewhere else. But I doubt that, because we could clearly see on the original one that it was fractured. Yeah, that there was a fracture in the thing itself. Okay. Let's see if I can persuade it to come out. I could use a bit of hot air. I might not the plastic. Oh yeah, it's coming. It's coming. It's coming. Just needs a little bit of help. Yeah. I think this one's still soldered. There you go. It's out. So let's get some resistors now. You see that wasn't totally successful because I actually ripped the pad off there. Yeah. But this is so easy to actually fix it, it's not a problem. So let's get some 4.7k resistors. I need a couple of those, 4 of those we can need. These 4k7s, yeah. 4k2s. They'll do. No, they're 4k7. So we get a few of these, yeah. Some more there. Okay. And I'm just going to lash these on for now, just for testing, yeah. We can make this tidy, but just for now, just so we can actually test to see if this is the problem, yeah. So we can get a bit of solder back on these. And I could stick them on the other side, but just for now, let's just see if we can just persuade them to go on. See, this PCB is not the best, is it? I mean, you can see that the things are lifting off, yeah, the pads. It's obviously not up to much rework, is it? Although I've been slightly brutal with it, to be honest. So stick one in here for now. The other one off, because it's ripped the pad off the board, we'll have to go from here, so we can get over here where the audio comes in. We can stick one here, yeah. Get some solder on that one. A bit of flux might help. I'll just dab the solder line a bit into flux, basically. Come on, melt. Okay, that's on there. This one we can just solder to the other resistor for now. And if this works satisfactorily, we can just make it a bit tidier. I'll do it from the other side, yeah. But I just want to prove a point, really. Okay. So we have our two resistors soldered there, and we'll do the same on the other channel. Let's see if we can make this one a little bit more tidy. So we'll just twisted two of the legs together, yeah, and see if I just solder to this hole here. So if this works, I can always do it from the other side, and then this will be good enough until I actually get the right part, yeah. But we'll know for certain if this works that is what was causing the problem. So that's there. Okay. Go to that hole there. Okay. And then the last one into this hole here. Yeah. Okay. So we've now effectively set our volume control to 50%. Basically, you can see that I've soldered that on there. This just wants to be, doesn't want to shorten against anything here, the LED. So you can see that soldered there, they both soldered to the middle, this one to this end, and again from either end, both soldered to the middle, yeah? So that's our little ghetto mod, yeah? Let's see what it does now. Let's give it some audio. Let's switch the power on. It's quite clear. It's quite clear. This has more than one problem. I certainly have both speakers working. I definitely have both speakers working now, but either here where the wires come in, or quite possibly here is obviously bad, yeah. So the next thing with this is going to be to basically the audio input which comes through the back of here. I think I need to cut this off, yeah. You can hear that. I think what this is becoming worse, but now we need to fix it because I want it working, yeah. So the audio in coming from the mixer, which is this one, yeah. Either where it comes through the hole here, or where this soldered to the actual PCB here, or somewhere in here, there's a bad connection, yeah. So I think the thing with this now is going to be to clear all the glue off here, feed it another 6 inches of cable through, yeah, and then solder it back onto here, and once again we'll see if we found the problem. Okay, see you soon. Hey guys, it's tomorrow already. I was just trying to fix this before I went home last night, and I was rushing a little bit, to be quite honest. So we still have this intermittent problem, but what I noticed this morning quite clearly is this one's broke. This pin down here, yeah, this track here, it should connect to the audio input here, and I'm sure you can see if I waggle that around a bit, it's broke. So the problem with these sort of single-sided cheap brown circuit boards, they're made of like paper and resin basically, bonded together, and they're not very good. The tracks don't stick to the board that well, and after they've been heated a few times they just come off, yeah. But it's not really a problem because they're also easy to fix. Because it's a single-sided board, so if we have a broken PCB like this, we can easily just tag a bit of wire across to where we need to go, yeah. So what I'm going to do is I'm just going to take this the end of this resistor back off again from the board. Try not to burn my fingers while I do it. Let's use the long nose pliers, yeah. Let's just stay safe on the fingers. It's got a bit of the PCB track attached to it, so there it is. Okay, that's now off there, and we can just clean it up. It's not, yeah, it's also not a very good connection at the other end either. So I was rushing last night. I was thinking I'll get this done and I'll upload this video, and it wasn't obviously the best of ideas, yeah. So a little bit more careful at it. We'll just bit of solder on here where we're going to tag the resistor, yeah. Okay, that's now on properly. Let me just see what's happening at the other end. It seems to be waggling around. Yeah, it's not soldered where it goes through the into the ground here either. So that was also another bad bit of soldering yesterday in a rush. Bit of more solder on that. That's firmly on now. That's all on there now, and we should be able to see. We can just check it actually with the meter, yeah. So I just get the meter probes all tangled up in the wires. There we go. So from the audio coming in here, yeah, to ground should be 4.7, yeah, 4.7 kilo ohms, onto the ohms range. In fact, we can pick up ground here, yeah, we know that's ground, so we should see 4.7k. 48 ohms, that surprises me. Okay, we see some resistance. What's on the other one? 52. Oh, they're about the same. For whatever reason, I must be reading the resistance of something else in parallel with this. Okay, that's good. And then from the center point here, which is this effectively. Oh, I see now. That isn't. That's measuring from here to here. Yeah, that ground is effectively this end of the resistors. These are ground, yeah. I need to measure from here to the middle. Okay, 2.1, 2.1. They're both really the same. So I think I've now got these wires all on properly, yeah. Without cleaning all this flux off them. It's a bit hard to see, but I'm sure we have from this point here, goes down to this pad here, and we can test that. So this here should go to the junction of these two resistors. So let's just go up here somewhere. Yeah, it does. So that's a good connection. And the other one Where does the other one actually go to? Get my magnifier a moment. Let me have a look. Oh yeah, I see. Okay, the other one just goes to a pad just below here, yeah? Okay. So that is all connected now. So what we need to do now is try again with a bit of audio and see if that's working. So now, so this speaker's working. This speaker's working. Do I still have a bad connection? Don't tell me YouTube just stopped playing, yeah? Let's have a look why that's just gone off. There's nothing coming out the mixer anymore. Oh, in fact I didn't have to do. Yeah, that wasn't the speakers. I can see on the mixer there was no audio coming out, so obviously I have a bad internet connection this morning. I'll just restart the router in a minute. Okay, so that's working. What I can do is I'll have a look on AliExpress and see how much a replacement, a proper replacement potentiometer is, because obviously this one we can see is clearly fractured here, yeah? And then once we remove this, because the traction's not very good, we then cause more problems ourselves, and we have to fix them. This one I can't really use because you see this is 100k, but the other side there's 50k. That's unusual. So you got a 100 and a 50 both in the same double potentiometers. That's a little bit unusual, yeah. So what I'll probably do is have a look to see if we can find see if we can find a suitable replacement on AliExpress. I mean, for now I can leave these resistors in here. This is a ghetto mod, yeah. This is to get you out of trouble. I can stick them in from the other side and just bend them through the holes to the right places, solder them in and leave them for now. And I've got 2 working speakers which I can control from my mixer, and I will order. So let's have a look, see if we can actually get one of these and if they're cheap. Okay, yeah, I had a look on AliExpress. To be quite honest, most of them are the B-type, the linear ones, yeah. So I had to have a bit of a look around, and eventually I did find some of the A-type. This says A103, yeah. So the 3 is 3 zeros, that's 10,000. That's the same as saying A10K. Yeah, A10K, A103, it's the same thing. In fact, it says here A10K, yeah. 6 pin straight, although it's showing different types here. It says this is for 6 pin straight, so you get 2 of them. 215 plus supposedly 315. It's €3.60 or something. So it's worth me fixing this, to be quite honest. I'll sign in when I finish the video, and I'll just order. That gives me one and a spare one for something else in the future. For now, I can use this with the resistors. It's fine for what I need to do with it. It's got it up and running. I'll just have to put the resistors on the other side of the board, yeah, because there's plenty of space the other side in here. Can you see where they'll go? So I can put the resistors this side. Any track damage, once I replace the potentiometer where the pin comes through, I can just tag a wire to wherever it needs to go if I get any more track damage. So we'll call that one repaired. It'll work for now, and in a few weeks when the parts turn up, I'll have a good potentiometer to fit in there. Okay guys, see you on the next one.